Hello, and thank you for joining me as we begin our last unit of this semester. Today we're going to talk about stability and bonding. So this unit, we're going to learn how to write and name compounds correctly. And so to do that, we're going to start at the beginning and kind of build our way up. So to start with, we're going to talk stability and bonding, which is going to be a little bit of review, and then we'll progress into new material shortly after. So today, you're going to describe how a compound is different from its components. We're going to look at differences there. It'll tell me what a chemical formula represents, which we've done before. We're going to review it again. I want you to explain how the electric force is important in forming compounds, and we'll talk about that. And then why does chemical bonding occur? That's our last task and goal for the day, for this lesson. So for starters, what is this picture here? And you should know that's the Statue of Liberty. Okay, second question, what's it made out of? Maybe you know, maybe you don't. That's made out of copper. And so my final question is, why is it green? Because copper doesn't look like that. And so to answer that question, we have to know a little bit about chemistry. And so copper, which looks like this, reacts with air to form a substance known as copper oxide and copper sulfate. So copper sulfate forms from copper and sulfate that's found in the air, and then copper oxide, obviously there's oxygen there. But that's going to turn so it looks this color. So we went from a nice brownish copper color to green. Lovely. Compounds. We've talked about compounds before, but compounds are substances that contain properties that are not present in the elements that make them up. For example, we have a substance called sodium chloride. You probably know it better as table salt. Most people like table salt. It goes great on mashed potatoes, French fries. Yeah, salt's a good thing. Salt is made of sodium and chlorine. Sodium is this substance over here. This is a soft, shiny, silvery metal. This is sodium in its elemental form. This container, which is green, is chlorine gas. Now, sodium, while it's a metal, is also toxic to consume. So if you would eat this, you would get sodium poisoning, which wouldn't go well for you. You would be at the ER. Your wallet would not enjoy that. Your parents would not like that. But that's sodium. Chlorine is poisonous. This will kill you if you breathe in too much of it. And so we combine a toxic metal with a poisonous gas, and we get our favorite flavor additive. Makes total sense. But compounds have properties that aren't present in these two individual substances, and that's how it works. So together they form something that we really like. Chemical formula is how we represent these, and these tell, like we've talked before, they tell what elements a compound contains and the exact number of atoms of each element in one unit of the compound. So for example, what elements are present here? And so you should say Na is sodium and Cl is chlorine. Then the question is, how many do I have? And so because there's no numbers, I have one sodium and I have one chlorine. Down here, you should be familiar with this. This is water. So water is made of, H stands for hydrogen and O stands for oxygen. How many do I have of each? Well, the little 2 here means I have 2 hydrogens. This is called a subscript. And there's nothing behind the O, so I only have 1 oxygen. But those are chemical formulas. These are some familiar compounds, some things that you'll see in your daily lives. And these are chemical formulas that are associated with them. So things like cane sugar is C12H22O11. Vinegar is CH3COOH. Battery acids, H2SO4. Stomach acid, HCl. Those are just some different compounds. You'll be able to name those by the end of this unit. So really quick, kind of a midsection review. I want you to just pause the video. What is a chemical formula? What does it tell us about compounds? And give me an example of a compound. When you're done with that, hit play and we'll continue on. So the next question is, so compounds form when elements combine. So why do elements combine? And to answer this, we need to think back. What do you know about group 1 metals? Are they reactive, yes or no? And if you remember, group 1 metals have 1 valence electron, and they want to have 0. So they're going to Get rid of this, so yes, they're very reactive. Group 17 nonmetals have 7 valence electrons. They want to have 8. And so they're going to want to gain 1. Yes, they're very reactive. We talked a little bit about noble gases. Do these guys react? The answer is no, they don't. They're kind of like those snobs that stick their noses in the air and think they're too good for everybody else. They want to be left alone. But why is that? And that is because, this is looking at stability, you have your group 1 elements all have this one red dot on the outside, which is 1 valence electron. Group 2, your second family alkaline earth metals have 2 red dots on the outside. We skip the transition metals, jump to boron's family, has 3 valence electrons, carbon has 4, nitrogen has 5, so does phosphorus, everything down the column does. Oxygen has 6, fluorine's got 7, and these guys have 8. Except for helium, helium's got 2 because this first shell only holds 2 electrons. And so in order to be stable, atoms need to have a full outer shell. Remember, hydrogen and helium only need 2 valence electrons, while the rest of the elements need 8 in their outer shell. So how do elements go about filling those shells? And to answer that, we look at electrons, and they either gain, lose, or share those electrons in order to become stable and have a full shell. So really quick, I want you to draw a sodium and chlorine atom with all their energy levels. So this is sodium, and this is chlorine. You will notice sodium has 1 electron in the outer shell. Chlorine has 1, 2, 3, 4, 5, 6, 7. So chlorine wants to have 8. Sodium wants to have a full shell, but it's easier to lose 1 and make this our outer shell than it is to gain 7 more. So this electron is going to jump to here and take that spot. So chlorine is going to have a negative charge. Sodium is going to have a positive charge, and opposites attract to become chemically bonded. We're going to talk about this. So now if you draw dot diagrams, this is a little bit easier. So dot diagrams are just valence electrons. And we're going to take this dot here and we're going to insert it over here. So chlorine becomes negative and sodium again becomes positive. Your couple quick questions and we'll finish up. So how many electrons can atoms hold in their outer shell outside of hydrogen and helium? And then how do they go about filling that outer shell? So what ways do they use to fill that? All right, the last little bit. The chemical formula for water is H2O. If we draw electron dot diagrams for this, we have H2O. What we can do here is we know that oxygen needs 2 and hydrogen needs 1. So we can take and we can rotate this so that your hydrogen matches up right here. And your hydrogen is going to match up right there to form a water molecule that looks like this. So in sodium and chlorine, they transferred. Sodium lost, chlorine gained. This one, they are sharing. And that's a different kind of chemical bond that we're going to talk about here shortly. But this is going to be a water molecule, and the goal is to become stable. So a chemical bond is what is formed in both cases. Chemical bonds are a force that holds atoms together in a molecule. So you'll need that definition for chemical bond. That's a force that holds atoms together in a molecule. And the way it works is you have positives in the middle, you have negatives on the outside. When you have more positives than negatives, you become a positive ion. When you have less positives than negatives, you become a negative ion, and opposites attract. That is your electric force that pulls those two things together. This is chemical bonds. Here are some review questions quick. So how many valence electrons do elements need to be stable? How do they achieve stability? And what is a chemical bond? So answer those, and then you are free to go for today. Thank you for your time and attention. If you have questions, please let me know. Otherwise, I will see you next time as we continue to learn about writing and naming chemical formulas.